Welcome back to the Automation Podcast. My name is Sean Tierney from Insights in Automation, and this week on the show, I meet up with Mitch Holdren from Mettler, Toledo to learn all about their new smart single-point load cell with integrated I/O link. Mitch, thank you for coming on the show. Really looking forward to learning all about this load cell. But before we jump into your presentation, could you first start by introducing yourself to our audience?
Yes, absolutely. And thank you, Sean, for having us. Really appreciate it. So my name is Mitch Holdren, and I am a business development manager for Mettler Toledo, representing OEM products for North America. So in my 8-year tenure here at Mettler Toledo, I've had a number of interesting roles that have been in our industrial division, which we'll talk to you about here in just a minute. Among them being responsible for application support, also spending some time as a product manager for these awesome products. And again, now that leads me to my current role as a business development manager. So really happy to bring this kind of information to your audience, to viewership, because we're really excited about it. And in fact, we're ready to go today to show you about what we call our SLP33XD Smart Single Point Load Cell. So it's got integrated I/O link connectivity and condition monitoring.
Nice.
So a little bit about us, Mettler Toledo. So solutions across a value chain. If we look inside of a business, it could very much look like this, from laboratory solutions, process analytics, industrial weighing, product inspection, logistics solutions, even retail solutions. So if you're at the deli counter or you're looking at produce, we also do precision measurement. We do scales, and a lot of other precision measurement. We have got a lot of that technology with us. So leading global manufacturer and marketer of precision instruments and services for use in laboratories and manufacturing. That's what we do. That's who we are. We're among the largest, if not the largest, precision measurement company in the world. We do have production facilities in Europe, the Americas, and Asia. So we have global products. So especially when we get into cases where we have things going on the other side of the world, we have equipment getting shipped. It's good to know that you have someone on the other side of the globe that has the same product, right? That has the same capability to be able to install, to troubleshoot, to do all of those things. And then again, with global approvals, right? You want to be ready, you want to be prepared wherever you go around the world, and that's what we can help you do. Market organizations in 40 countries, so direct representation, offering full support and service. 9,100 local sales, marketing, and service specialists. We're split equally across regions. So if you look at the Americas, you look at Europe, and you look at the Asia Pacific regions, hey, we have a pretty large and an even footprint in all of those regions. Again, well-qualified and factory-trained distributors in all other regions. That's about another, I think, out of 140, give or take, countries, it's about another 100. So wherever that is that this equipment goes, you're going to have someone who's well-trained, well-qualified to be able to not only speak to it, but also to be able to make sure that it's prepared and taken care of. Again, today representing our industrial weighing division. And when we talk about why do we want to weigh accurately, honestly, in many applications, and you see some here, so life sciences, dynamic parcel weighing, formulation, semiconductor and battery manufacturing applications, high and low speed filling, you do active ingredients, even storage and production. In many of these applications, weighing is the most accurate, convenient, and repeatable method to measure. It's certainly not the only, but again, when we're talking about critical applications, when we're talking about the need to eke the most performance out of machines, weighing is a very good way to do it, and we're going to show you how today. When we talk about 4 elements for precise control, hey, we're gonna do this, and at the same time, to remove some of the burden from the control system by doing it. So with this single point load cell, we can run this at speeds up to 200 hertz. So we're not waiting on the measurement, all right? And because that weight is deterministic at predictable intervals, you're not waiting on, and you're not getting inconsistent information and waiting on it, right? When you look at, your typical bidirectional communication where you have to have a send and acknowledge all of this, It's not, hey, I missed a message, another one will be along shortly. That leads to delays in communication, and it leads to poor control. So, hey, we want to avoid that at all costs, and this is how we can help. We talk about dynamic vibration filters to remove mechanical noise. At the end of the day, industrial environments are very, very tough. When you look at inside of machine integration, that's also very tough. All right, so we want to make sure that we're not adding to those issues. We're actually helping to take that away. But in not having passive filtering and not doing mechanical or averaging, again, when we get into passive filters, that really takes a lot of resource, and it ends up slowing the process down. Ultimately, all of these things lead to low latency, so there's no delays in weight response. What happens is, as soon as we change the weight, we want to see that reflected, and we want to know that it's the true weight. And again, all of these 4 elements really drive faster machine, right? They boost productivity. So what does this mean for today's smart factory and tomorrow's smart factory? Hey, ultimately, it's an automated manufacturing facility. It uses connected devices, machinery, production systems to continuously collect and share data, right? That data is then used to inform decisions, to improve processes, and address any issues that may arise. I mean, hey, we know that every day, every manufacturing process will have issues. Okay, it's a foregone conclusion. But when we look at how smart sensors, how automation, condition monitoring as part of that, right? Seamless connectivity. Hey, you need consistent accuracy for good quality production. And what we're seeing with IT and OT convergence, plug and play, all of these are enabling that smarter decision making to come from the plant floor all the way up through to the boardroom, right? When we look at the ISA model, from level 0 all the way up through the top, this is where we're seeing the biggest push forward, the biggest movement. And but hey, we're really, really happy to make sure that we're watching these trends not only, but making sure that our products and our go forward and our ability to help customers in this area, whether they're machine builders or whether they're end users alike, that they're ready and prepared, and that we can help prepare them with our products and services. Talk a little bit about smart sensors. The characteristics of one plays a very, very important role, right? So have to communicate to control devices and or the cloud. Really, the cloud is just not a cloud, it's just somebody else's computer. But hey, that's varied. We're not going to talk a lot about that right now. Ultimately, the main takeaway from all of these points is that just the physical characteristic or measurement is not enough these days, right? We need to process that data. We need to make sure that it's more accurate. We need to give more, more context, right? When we talk about signs of life, a heartbeat, there aren't necessarily people that are right in front to be able to take a look and say that it's okay. So how does the system know that this is working? Self-diagnosing, condition monitoring, and alarming to say, hey, look, I know when I'm in a good condition, and I want to tell you right away when I'm not. Ultimately, that's going to lead to better performance. It's going to lead to less downstream problems. And this is really where we want to be. And overall, if you've got something that's got additional smarts, additional sensors, additional inputs, algorithms, all of those things, when you put it together, you're going to be able to tune it better. You're going to be able to provide a better measurement sensor to begin with. So when we talk about weighing automation for machine-to-machine communication, hey, 2 things really pop out. One, predominantly chief amongst end users. When we look at engineering, procurement, construction, we're looking at entire factories, control systems engineers and equipment builders inside of those factories. Industrial Ethernet, the power that you get out of it, right? To be able to transmit that much information and be able to do it easily, to get that speed, to get high bandwidth, that's going to be able to allow you to pass all that information from the floor up. And then, hey, when we look at IO Link, we're looking at 200 hertz speed. We're looking at lower bandwidth, lower order things, right? So generally speaking, we see this more common amongst machine builders. And again, 2 primary strategies moving forward from an OT perspective here. Speaking of which, hey, what is IO Link? For those who may not know, it's a standardized industrial interface. It's supported by manufacturers. A lot of them you see here. So Mettler Toledo is an IO Link member, right? So if you've got a B&R system, a Schneider system, Omron, Beckhoff, Rockwell, and you see Emerson and others, yeah, can you connect IO Link to those systems? Absolutely, yes, you can. You know, it's a low-cost plug-and-play technology for sensors and actuators. Again, level 0, low level. All right. So we need an IO Link master to be able to get to higher order systems. Good news, we've already got 24-volt sensor power on as part of the standards. Speaking of which, cables and connectors, right? There is a standard. They're easy, they're off the shelf, ready to go. Simple, unique protocol. In our case, weight data is included as a result. And what we're seeing is it's replacing a lot of device net and CAN use, you know, from legacy machines as they're upgraded. And if you want to find out more, there's a link below. You can see io-link.com. So now that we've seen what is IO Link, let's talk a little bit about why. Again, you know, sensors are installed, in this case, in one of many automation systems via an IO Link master. It's a standardized interface, right? So there's no learning efforts for OEMs, machine builders, even system fabricators. It's easy to integrate remote parameterization, so setup, maintenance is even possible. We're going to talk about the software associated with that. But ultimately, what it comes down to is it's very, very easy to install and maintain, right? Straightforward installation, standard cables and connectors. There's no proprietary connections. There's no hard wiring necessary. Super, super easy. Okay, so hey, we're following this down the chain. What is a single point load cell? Now we're into the weighing part of this bit. So ultimately, a single point load cell allows you to build a scale with just a single sensor. So when you look here, right to my right, to your left, ultimately the load cell is the thing that measures the deformation under load via strain gauges. So on the top where you see the white, underneath that, there's some electronics, you know, whether you call it a Windsor bridge or exactly what you call it. The idea is that we're taking that change in resistance as a result of the cell being bent when load is applied to it. And we're taking and amplifying that millivolt signal. We're doing the analog to digital conversion, right? We then apply digital signal processing, filtering, right? Well, then we take that and we scale that electronic value to pounds or kilograms and provide that to the system, right? We also have the capability to allow some basic control. Zero and tare are common scale commands. You know, we offer linearity adjustment, so now we can tune, and we'll talk a little bit about that. And again, transmission of that weight value is very easily. So we do all of that inside of the load cell itself, right? It's one load cell to build this particular kinds of scale, and all of these functions are integrated. And guess what? If the weight alone weren't enough, so it's not enough just to have that. Remember, that's one of the conditions that we have of the smart sensor in smart manufacturing, is those onboard electronics do also provide additional context, and we'll show you a little bit of that later on too. So for this particular load cell, the X actually does represent something. So when we said at 33XD, it's either 331D, 332D, or 333D. And those have a little bit to do with the physical size and capacity of the cell. And we'll show you some of the mechanical bits here a little bit later on. Just know that the entire family can take you from about 5 kilograms of capacity, or 11 pounds, to 500 kgs, or about 1,100 pounds. So it covers a very, very wide range with just one cell. Hey, from our perspective, this is industry's most modern single point load cell. It's a solution for a lot of different things. One, first and foremost, to eliminate a weighing electronic. When you have a load cell, a single point standard load cell, it's got an integral cable, and the cable goes back, and you wire that into an indicator or transmitter, which is another piece of electronics. With this load cell, we can eliminate the need for that electronic. It's another source of failure, right? It's another component in the chain, And it also adds uncertainty because of the pairing between the two. If you can do all of that inside of the cell and eliminate a second piece, you're actually simplifying things and you can actually tune it a little bit better. You know, one of the things that we're really starting to see is limited cabinet space. So, machines are getting smaller, real estate's getting expensive to maintain the same kind of production density inside a facility. So if you can make a smaller machine that still works and still is just as fast, and you can make it using less components, it's going to be less cost overall, and you're going to be getting incredible value from as a customer buying that equipment. So design is always being pushed down. So if you have limited cabinet space or no cabinet space to put that weighing electronic, good news. As long as you already have an IO-Link master on the machine, chances are you've got that for some other sensors. Hey, you're going to be able to plug right in and you're going to go. You don't need that large cabinet for weighing electronics. Saving time, connecting and weighing, whether it's you building the machine, commissioning it, or after handoff, it goes to a customer and they may have to maintain some or all of it. It's going to be easy for everybody. Eliminating complicated calibration with test weights. So to this point, I will say there's a slight asterisk here. If your process does require calibration by test weight, this is totally and absolutely possible, no problem. But where it's not necessarily required or only required at specific intervals, and again, that's all part of quality plan that should be discussed when considering building a machine and the parameters thereof. But one of the things that makes it really tough is that with machines, there are a lot of guards in place. There are a lot of places where you've got platforms underneath and you don't really have good, easy access to be able to handle a test weight to actually get this thing to work to start with. So the good news is we'll show you here in just a little bit of how you can do that immediately and easily right from startup. So you take this thing, you plug it in, you integrate it mechanically, and you're good to go. Save you a lot of time and a lot of headache. You don't need to buy test weights just to get it to talk. We're going to talk about future proofing, right? This is new technology. Traditional cells are not future safe. Again, they're bulky, they're clunky. We'll talk about some of the maintenance aspects of them in a little bit as well. But if you want to take that next step, this is a great way to do it. Improve weighing speed. At this point, we're 200 hertz. We're approaching the speed of actually having to wait on gravity to get the load cell to bend to get the result. So the good news is you're not waiting on the result and having that slow your process down. There's nothing we can do about gravity. We'll try to speed it up for anybody that wants to, but hey, for now, gravity's as good as we can go. Condition monitoring. Again, once you get continuous update of status, as soon as something changes in that cell that says, hey, we shouldn't trust the weight, that automation system gets it immediately so that you're not wondering. One of the things that can happen is, let's say a cable gets nicked. And we'll talk about the rest of that maintenance here in just a few slides. But when it comes down to it, the first thing that you need to know, and you need to know immediately, is that we should no longer trust the measurement. This is the context that you get with condition monitoring that you don't get with a traditional sensor. Again, lower service costs. We'll talk about that in just a minute, but hey, the cable, it's not integral here. You can just replace the cable and you can get it from anywhere off the shelf. You can do it in about 10 minutes, probably less even. A simplifying service, yes, part and parcel. On top of this, we'll show you on the cell itself where you can identify it, right? So if you don't have access to the automation system and you want to see whether the cell's doing okay or not, you can see it right on the side. It's a multicolored LED, and we'll explain that function. And again, best-in-class accuracy. We do that because we can tune it, right? We don't have to send it down a long cable and into another electronic, right? We're not subjecting that to EMI and RFI inside of an industrial facility, inside of a noisy machine that's got a lot of electronics, VFDs, everything else running. So you get a good solid signal and you get it quickly, you get a lot of context behind it, and you get it without a lot of muss and fuss and physical, mechanical, hard labor to a hardwire stuff. Let's talk about weighing performance for just a second here. When we talk about built-in filtering, you're getting that stable weight signal. And hey, when you know that you're not getting noise from the electronics, we're down to about 10 parts per million. It's about 5 times as good as your average cell with the A to D and the filtering that we've got now. Very, very, very low noise, right? So what happens when you start running products across it? You get that dynamic accuracy because you know that, hey, when this thing is stable in its normal output that you can see across that graph here, that it's not going to be also adding noise to what you see. Okay, after a very, very brief startup period, that's the curve on the very, very left of the graph. You can see that, even after 15 minutes and after 3 hours, this thing is really, really, really dialed in, right? So up to 300,000 divisions or individual graduations, that's noise-free resolution. Fantastic. And again, that enables the rest of your signal processing to work and to give you the speed that you need, right? So now you can turn up your belts faster, you can run your machine faster, and you're still going to get that stability. Talk about factory adjustment for high accuracy. So linearity, I used that word earlier. You're going to see it here. Ultimately, when you look at a cell performance in loading and in unloading, because we're still beholden to material properties, right? The metal, that chunk of metal that the load cell is made out of. Hey, there are some differences. When you look at traditional load cells, C3 accuracy class, those are batch manufactured. And the cable is going to be integral to that performance. Here, we can actually take everything in that envelope, right? Your loading and unloading profile, and we can squash that. And we can make it, we take all of the little minor inconsistencies in the metal and the gauge bonding process, and we can eliminate that as a source of uncertainty. So that when you get these things and you put them into your machine, if you have to put one in, you have to put a second one in, right? If you've got multiple inside of the same machine, these things are almost identical copies of one another. And yet that's how we go from yesterday to today's. So you're going to get higher yield out of the same thing, and you're not going to have to, go and tune these things with test weights and spend a lot of time moving back and forth. You're going to get that directly from the factory. So we talk about OIML, so European Legal for Trade C3, C6 accuracy classes. And again, on installation, only the geocode, the local gravity value. So it's it's kind of a combination of your latitude and relative local altitude. So I don't know, kind of a fun fact, once you're at the equator, that's about the heaviest that you're going to weigh, and you only get lighter from there. And the approximate effect for every degree in latitude that you change is about 61 milligrams per kilogram of applied load. So hey, that's a fun thing to, I don't know if throw it out at parties or whatever, but hey, at the end of the day, those things do matter. So we have the capability to say, hey, are you in, pick a location. We do have a geocode value for that. There are, 0 to 31 or 1 to 32, and you put that number in, and that's all that you have to remember. So if you build a machine and do factory acceptance in one part of either the US or Europe, you can then send it someplace else, and all you have to do is change the geocode, and you know that you're dialed back in. And again, if you need to, you can certainly apply test weights, receive a calibration, right? And at that point, you know that you're good. From a quality perspective, if you need to tie results to a traceable national or international standard, that's exactly what Mettler Toledo can help you do. So industry standard alarming. So one of the things that you get with condition monitoring, and we see, even more so now that industrial Ethernet has really, really come online inside of factories, is you get a lot more information. So, before we never used to get this kind of information, and now what's happening is sometimes you get alarm floods, right? You're getting just overwhelmed, whether it's operators or automation systems, with information. You don't know how to process it, which is important, which isn't. This is something that we implemented in accordance with industry standards. So you're going to see NOMWAR NE 107, ISA TR 18.2.2, and IEC 62682. These are industry standards for alarm indication. So, and what you see here is alarm priority. And you also see that reflected in the LED lights. So this is not something that Mettler Toledo came up with, but it's something that our customers really producing customers said, hey, look, we need a way to understand how our devices are working in our machines in our factories, and we chose to adopt that. So this is something that they worked on very, very hard and continue to monitor and work and adjust and adapt. And this is something that we implemented into our products because it's really, really needed. Again, instant notification, what you see on the LED is also being sent via routine update to the automation system. So we talk about the data, inside of that cyclic data, you do get the condition monitoring. So if you're looking bitwise all the way over on the right, you start at least significant bit and you go all the way over. You got 64 bits that's transmitted. First 32 is going to be your weight value, okay? And after that, your Smart 5 alarms, those 5 colors that we talked about, are going to come in as well. And they're going to be in that 4th and 5th octet, right? Your second 32 bits. And what we see, you see our orange, yellow, our blue, Smart Alarm level 5, level 4, level 3. Hey, really, if there's nothing else that you take away, number 5, the red one, that means can't trust the weight. Stop right now. You really should check. Something's really, really wrong. So you're able to just monitor that bit. The bit goes high, then you know that something's really, really wrong. So it doesn't take long to implement it. You don't have to dig and dig and dig for days to program. You get at a glance very, very quickly the status of this along with the weight value, so you know when to trust it. Again, additional condition information available. So everything that you see in green here, like net mode, whether somebody has pressed tear, and that's okay. So whether you're looking at gross weight or tear weight, whether the scale is in motion. So, when you place something on, you want to take a stable measurement if it's needed, then you need to know when that platform it stops moving. We can provide that indication so that you don't have to look and tie up resources in your automation system to do that. Same for center of zero, right? When we place something on the scale and we take it off, we want to know that it's back to 0. We give that indication. Data okay? Hey, that's pretty straightforward, right? It just means that, hey, we're in a good condition to send and receive information. And your heartbeat, right? So that's just a 1 hertz toggle back and forth, and you set a watchdog around that. So as long as that heartbeat's going, you know that even if you're not seeing information, you're not requesting it, then you know that, hey, it's still there. We're still talking. And as soon as that stops, hey, maybe somebody's disconnected a cable. There's something else wrong. We should go check. So on this slide, what we see is capacities and sizes. So we have the SLP 331D, 332D, and 333D, covering that 5 kilograms all the way up to 500 kg range. And you can see some of the form factors. We have 2 different accuracy classes, a standard accuracy class, that's our C3, and then we also have a C6 accuracy class, a higher accuracy class, right? More precision if you need it. But again, not all form factors are available in capacities, which is why we have this chart to help bring it along to let you know what's available so that you can help start to look and see that when you plan. We'll talk about where to get some additional resources here in just a second. We talk about mechanical integration for a second. Hey, versatile, large weighing platform dimensions are supported. This is going to help to put these into different machines, different sizes, different platforms, right? Not everything is the same. Just know that, hey, the load cell design itself, the single point, minimizes the effects of off-center, or what weighing people call eccentric loading. Okay, so with these load cells, and you see the dimensions here, the 331 and 332D support up to 400 millimeter by 400 millimeter length and width platforms. Again, that's about 16 by 16 inches. And then the largest of the three, the 333D, supports up to 600 millimeters by 600 millimeters, or almost 24 by 24 inches. Just keep in mind, the center of applied load is right in the middle of the cell. And when you're on either side of the cell, we'll take my handy clicker here and use that as a cell, one side underneath and one side above, you're going to want to create just a little bit of space because the cell will bend as load is applied. And again, we're not talking very much. We're, less than 0.35 millimeters or 14 thousandths of an inch. So it doesn't bend very much at all, but if you lay it flat from top to bottom, it doesn't give anywhere to bend. So those are really the only two things, right? So as long as your platform is within that envelope as it sits with the cell, you can integrate this, no problem. All off center loading is going to be accommodated for. So very, very, very flexible, easy to use. Scale capacity, keep in mind whatever you put on top of the load cell is going to reduce the platform's weight, right? You can adjust that out in setup so that you don't see the weight sitting on the load cell. That's part of the calibration and adjustment process. Very, very, very easy to do. You can zero that out, make sure that you don't see it in your everyday measurement. But it's going to, so if you had a 500 kg cell and for some reason you put 100 kg on top of that, you now have 400 kg remaining to be able to weigh whatever product or things you needed to weigh. Good news, once you install or on install or when you have to pull out and reinstall, you can do this in less than 10 minutes. Okay, so load cell has standard M12 industrial connectors. You can see it on the back here with the cable off and with the cable on, right? These are off-the-shelf cables, offer a lot of flexibility, low cost, and easy installation. You can determine as the machine builder what length cable to supply. There's no cable wrapping or excess cable required. And there's a note on the bottom here, right? Analog load cell cables are fixed in length. That's, the temperature compensation is built into the cell cable length. And what happens a lot of times is we see that, hey, I maybe ordered a 6-meter long cable. I really only need 2. I'm going to come in and chop it. What happens? Well, nothing good. The cell no longer operates as intended or designed. Well, okay. Second thing, if this is going to be way, way, way down in the bottom of a machine somewhere, and I have an integral cable that I've probably routed, I've probably had to either put through conduit or I've had to secure to keep it up out of things. Well, when I have to pull that cell, now I maybe have to undo all that. And all of these things are a pain, a real pain. So if you don't have to do it and you can just affix it via a simple M12 screw type connector, you're in, you're out, and then all you have to worry about is the cell, right? If you're building a machine, you can have that access right there, and you don't have to worry about that cable.
So that's a good point. So because it's purely a digital output, right? So there are IO-Link devices that send you an analog output plus some digital information, but this is purely a digital output. So your cable length doesn't matter. Do I understand that correctly?
That's correct. And because we're sending that 32-bit information, you're getting single precision floating point.
Yep.
So that you don't have any translation issues. Even
scaling issues.
There are formats that even weighing companies have used in the past, right? If you're looking at integer, well, if you've got a scale that's capable of putting out more than 3,000 or 32,767 increments of resolution, now all of a sudden you could have issues. Okay, so fine, we do double integer. We could do what was called divisions. That was another one. That required the programmer to know something about the scale, right? So that they could multiply it by 1s or 2s or 5s. And now they're hunting for a decimal point, and it's very, very easy to get lost and scale that and have a really, really large error. So the good news is single precision floating point, the number is the number. You don't have to mess with it. So
you don't have
very,
to
very
scale
easy
that.
to.
Yes.
That's right. That's right.
And one of the problems with a lot of electronics is they all have different scaling. So, but this would typically those other type of load cells would typically go back to your own device first before going on to the control system, correct? It would typically go to a display and okay. So I'll turn it back to you. Go ahead.
Sure. Well, and there even, Sean, thank you for bringing it up. There even is another interesting point. When we take from the cell, from analog converted to digital, and we're going back to, let's say, something on, 4 to 20 milliamp, that's actually converting it back into analog.
Exactly.
Right.
Yep.
So then there's some complexity on the backside of that. When you have your traceability from your analog to digital conversion, your certificate supplied there, no problem. Well, You also have to look at the output of your digital back to analog. You have to look at the cabling, make sure all that's good. You also have to check your input module, make sure that that voltage is right where it's supposed to be. Those parameters are okay. And then once you're done with all the hardware that has to be, physically wired, maintained, make sure that everything's good, then you've got to look at scaling in your program. So very, very complex. Hey, good news is everybody's been doing it for a long time, but these all have sometimes little, but oftentimes they have larger implications than people realize as part of that selection. So if you can get
Yeah,
that weight value in and not have any issues and not have to worry about it, it's a lossless format. Very,
yeah,
very easy. We've had a lot of good feedback on that. People love it.
it's definitely one of the biggest selling points about IO-Link. Your device is doing the conversion, and we're just getting that raw number. There's no second conversion being done. There's no worry about scaling because, was it 4 to 20? Was it 0 to 20? Was it plus or minus? It's done for you. You get that number, and it should overall, any device that you replace an analog with IO-Link, you should have much more accuracy. So I'm totally with you there.
Yep. I don't know of any machine that's gotten simpler as time has moved on. So we're trying our best to reduce that complexity wherever we can.
Yeah, absolutely.
Speaking of which, when you have projects or products that have to go around the globe, um, hey, we want to support global products having global approvals and global support itself, right? For commissioning, startup, etc. So when we look at metrology approvals, it doesn't matter where you're at. So NTEP in the US, OIML in Europe, and some other. You have CPA as well for Asia Pacific regions. Hazardous approvals, hey, all of this is pending, but it is planned. So we can't have everything all at once. As it turns out, it takes a lot of effort to make sure that things are right. Hey, when you're dealing with EX locations, ATEX for Europe, FM for US, Canada, NEPSI, and even more some of your other regions and what they accept. Hey, when it has to work and has to reduce the likelihood of an event that could cause to either ignite dust or vapors, hey, that's the highest order of safety, and we do take that seriously. So good news, eventually, hey, you'll hear more from us about that. But for today, we're going to be using these IO-Link load cells in a safe, unclassified, or non-hazardous area. And good news for people that are putting this into machines that have either humidity or water concerns, we also have ingress protection. In this case, we've got an IP67 rating on these load cells. So again, it's not something that always comes up. Hey, if you're working with dry products in safe areas in your backyard and it moves, maybe 20, 30 miles, then you're going to be okay. But if it has to go 4,000 miles around the globe, has to be in some of these other tougher conditions because, hey, let's face it, these are industrial machines that these often go into. Hey, just know that we've got your back, we've got you covered. So where can I find all of this information? Well, first things first, let's talk about IODD Finder. So where do you find the software that helps you install this load cell into your IO-Link master? Well, it's ioddfinder.io-link.com. You can either search by manufacturer, and we put that information here, or you can actually search by the model. Good news is, once you put that in, you're going to get the IODD file itself. You also have a manufacturer's declaration. And again, the downloads are going to be you only have to have two things to be able to download the file and make sure you've got the right one. It's going to be the product name, and the product name will have the model, and it will also have the capacity. So here you see SLP332D-IOL, that's short for IO-Link. That's the model, and then the capacity is 10 kg. So if you have those two pieces of information, you have it right on the cell itself, you can just go out to ioddfinder.io-link.com, pull that. Or, hey, if you don't remember that, you can always go to the Mettler Toledo website, mt.com/SLP33XD, and click on, you see that red square right there, that's the link that you want to click on that page, and that that will send you to a place where you can access product data sheets, installation videos. If this is your first time, we have videos available there to go see. Product certificates. So we talked about all of that on the previous slide, right? Whether if you need metrology certificates, if you need ingress protection certificates of that sort, that's all available there. We also have CAD drawings, both 2D and 3D available. And we also have a link back over to IODD Finder. So very, very easy to get to find, and it's a one-stop shop for when you absolutely need to have all that documentation when you're getting ready to make that final push into integration. So with that, I want to, hey, first and foremost, thank you, thank you, thank you. Second of all, from a question standpoint, if there's anything that's unclear, please feel free to reach out to us, comment, and we're more than happy to get back in touch with you. But yeah, if there's anything else, just let us know. Really appreciate the opportunity being on. And hey, from me and all of my colleagues at Mettler Toledo, thank you.
Well, and I want to thank you for coming on the show. I know weighing for me is not my expertise, but IO-Link is really taken our industry over by storm. As a matter of fact, a lot of the devices people have, they don't even know they have IO-Link in them, and they do. And so knowing that your company is supporting IO-Link, and it seems like, I mean, it's a home run. If you're buying a new system, you definitely need to check these out. You gave the website address, you gave them information on how to find the videos, the specs, the drawings. So I think you covered all your bases. So I guess all that's left to say is, Mitch, thank you for coming on the show. I really appreciate that. This is a great new product. I'm so happy to see you guys go in this direction with these load cells, and really appreciate you coming on.
Hey, thank you so much, Sean.
Well, I hope you enjoyed that episode, and I want to thank Mitch for taking time out of his busy schedule to come on the show and bring us all up to speed on their new single point load cell with integrated IO Link. I think you can really see the advantages of having IO Link built in and all those smart features that he went over. Now, if you did enjoy this episode, please give us a like, a sub, and a share. That is the fuel that keeps us on the air. Also, if you want to join our community or just follow us, you can do so over at automation.locals.com. And you'll also find all of my training courses over at theautomationschool.com. With that said, I want to wish you all an awesome, courageous, and fearless week. And until next time, my friends, peace.